this video we're going to look at drawing complexes involving bidentate ligands. So you should remember that bidentate, you'll get 1 mark for saying that it will donate 2 lone pairs of electrons, so 1 up to there, and then forming 2 coordinate bonds will always be your 2nd mark. Remember, they could ask you anything tetradentate, hexadentate, so for example tetradentate would mean donates 4 lone pairs of electrons to form 4 coordinate bonds. So just be aware of them asking something slightly different like that. Purpose of this video then is to get you practicing drawing complexes involving bidentate ligands. So we're going to start off simply, and we're going to start with the 2 most common ones on the spec. So this is the ethane diawate ion, sometimes known as oxalic acid, so it has this abbreviation. You might see a complex written as this. A minus, or you might see it written as this, and of course these two things mean the same thing, so you should be recognizing, if you see C2O4, you should recognize that as being oxalic acid. So if we get on to drawing, what I want you to do is to start by drawing a complex that would be square planar with this ligand. So let's do PT Ox 2, and let's make that uncharged because we'll have the platinum in a +4 oxidation state. So pause the video now. So we're going to draw a square planar complex involving 2 ox ligands with platinum. Carrying on then, the answer to this will be platinum in the middle. Draw the 4 bonds around it for square planar. Add the oxygens because these are the 2 bonding atoms, and then form the rest around it. Okay, so there we would have a square planar molecule, and if you were asked for the bond angle, it would of course be 90 degrees because it's square planar. In the second example that we're going to do, we're going to stick with oxalic acid. This time we're going to look at drawing an octahedral complex. So what I'd like to do is to draw the following compound. Which again, you might see written like that. But again, you should understand that that's the same thing. So pause the video now. I'd like you to draw an octahedral diagram of this complex. Okay, the answer for this then, so you start off by drawing your central nickel ion. You're adding your octahedral bonds around it. And then we're going to add the 3 ligands. So again, it's the oxygens that bond, and then we just fill in the rest of the molecule, joining those together. There's 1. There's the oxygens. Fill the rest of it in around. That's 2. Now a final one is there. Final thing we're going to do is add those square brackets and the charge. In the next example, we're going to use 1,2-diaminoethane, which is this. Again, this is a very common ligand to be used for the exam board. It's mentioned on the spec. So we're going to do a little bit of practice with this. So we're going to start off. I'd like to draw a square planar complex. You can use platinum as your central metal ion. So a square planar complex involving 2 of the En ligands and platinum as your central metal ion. Pause the video now. So the answer, we'll put the platinum in the middle, draw that square planar shape around it, it's the nitrogens in this molecule that have the lone pairs, so we put them on first, and then we just complete the rest of the molecule around it. There we go, and once again it's square plane, so the bond angle will be 90 degrees. So next example, sticking with this bidentate ligand, we're now going to draw the complex nickel En 3, and that's going to be 2 plus. Again, you might see this drawn as nickel with, let's see, we could put it as C2H4 H8 even N2. That would be a possibility, or nickel, no 2 there. They could write it structurally, I suppose, like this. It's a 3. So all we're saying is, watch out for different ways of drawing this ligand, but just be able to recognise that that's what it is. So what we're going to do is we're going to draw a nickel complex with 3 En ligands. Pause the video now as you have a go at it. And the answer, draw the nickel in the centre. There's 3 En ligands, this is obviously going to be octahedral. And then the same thing again, it's the nitrogens with the lone pair, so we put them on first. Fill the rest of the molecule in. There's one. Final one. Last thing, square brackets and the charge. So we're going to get slightly more complicated now, because OCR, like most exam boards, will try and find ways to challenge you and stretch you a little bit more. So they might give you an unfamiliar bidentate ligand. So let's have a look at an example of one of those next. Okay, so in this next example we've got an unfamiliar bidentate ligand. It's not one that's mentioned on the spec, but that doesn't mean that it can't be used in your exam. So you might get a question, it might say 2,2-bipyridyl is a bidentate ligand. What is meant by the term bidentate ligand? That would be a 2 marker. Then it might say that this forms the complex, an octahedral complex with nickel. Draw this complex. So let's make some notes of that. Octahedral with nickel. Pause the video whilst you have a go at it. So I'm going to draw the answer down here. There's my nickel. I've been told it's octahedral, so I'm going to draw the bonds around it. And then I'm going to look over here and think, okay, it's the nitrogens that have got the lone pairs on. So they are the atoms that are going on the bonds. Remember to always pick 2 bonds that are at 90 degrees. And then I'm going to fill the rest of the molecule in around that. Now some of these can be quite complicated, but essentially all you're doing here is copying what you've been given in the question. So difficult though it may be to draw, it's not actually out of the question that you could be given this. In fact, it came up in a very recent F325 exam. So there's one. Remember, it's easy enough to pick out the kind of bridge that's here and draw that on first. And then the rest of it is not too bad to fill in around that. That's 2. So there's that bridge again. And then I just fill in the rest of the hexagon. That end's not brilliant, but never mind. And that's 3. Then we've got to think about the charge. So nickel, common oxidation state is 2 plus. This ligand has no charge, so I'm going to put my square brackets. The charge on this complex is going to be 2 plus. Okay, let's stick with this ligand and let's use metal M and let's draw a square planar complex using this ligand. Okay, square planar, much easier to draw. Take your metal, add those ends, add that bridge, fill the rest in. And there we go. Okay, here we've got a slightly different way of asking a transition metal complex question. So we've got nickel forms complex with the ligand 1,2-diaminoethane. We've got the empirical formula of the complex and we've been asked to suggest a structure. So pause the video now if you want to have a go at this question before I go through the answer. Right, so first thing I'm going to look at in this is, so I know nickel's my central metal ion, and then I'm going to come over to the compound which is here, 1,2-diaminoethane. It's one of the ones that you should know, and it looks like this. So remember, this one's on the specification, so you should know this compound. And because I've been given an empirical formula over here, I'm going to write out the molecular formula of this ligand so that I can compare it with that empirical formula over here. So if I come now over to this empirical formula, I can ignore the nickel because I know that that's my central metal ion, and then I'm going to look at what's left. So if I try and take this away from what I've got here, so if I was to do that once, so that's what I'm starting with. Take one of them away, gives me C4, H16 and 4. Take another one away. So I can see that this complex contains 3 lots of this ligand, and then I'm left with the Cl2, which didn't get used up. Now you should be getting used to the fact that because transition metal complexes are generally ions, they will have an oppositely charged ion to balance out the charge, so we'll come back to that in a minute. But we're going to start off with suggesting the structure. So we're going to draw the nickel in the middle. We've identified that there are 3 of these ligands, and we should know that this one is bidentate because each of these nitrogens has a lone pair on it. So that means that this nickel is going to be 6 coordinate, which means that it's going to be octahedral. So there is the nickel in the middle. and then we're just going to add those ligands around it like we have been doing all the way through. Okay, so we've got our nickel with 3 of the 1,2-diamine or ethane ligands around it. Now we're going to come back to that chlorine or the chloride that's in this complex. So we didn't use the 2 Cls as part of the formula of the complex, therefore that means that we've got 2 lots of Cl minus in solution with this ion. So if we've got 2 negative ions, then that must mean that the charge on this complex is going to be 2 plus. In this next example, we've got quite a lot of information going on, and this question is really tough. So, saying the ligand acetyl acetophenone, known as ACAC or ACAC, is shown below. So this is the ligand, and this forms a square planar complex with copper, and it's shown here. So we look, here is one lot of the ligand, and here is the other. Okay, now an interesting thing happens with this ligand. We get some altered form of bonding here. But again, all we need to do is copy the picture. So, with nickel 2+, this ligand forms an octahedral complex with the formula shown here. So this is an empirical formula, suggests a structure for this complex. So let's look at this ligand up here. We go 1, 2, 3, 4, 5 carbons. Hydrogens are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 2 oxygens. So come down here again, we do a little bit of subtraction, so C10, that's 2, so we're looking at making 2 of these, which would be C10H18O4, take that away and we're left with, carbons are gone, we've got 2 hydrogens left and 2 oxygens left, so we'll come back to that in a minute. So we know that we're using 2 times this ligand, and then we look back down here, so if it's octahedral, this is only going to use up 4 bonds, so we need to make another 2 ligands out of this. So if we've got 2 O's and 2 H's, and we need to make 2 ligands, we're going to have 2 times the hydroxide or hydroxo ligand. We're going to get on to drawing this complex then, so we put our nickel in the centre. We've been told it's octahedral, so I'll put the bonds around it. There we go. And then we're going to start adding ligands. So we'll start with these 2 over here. There we go. Again, you're probably already thinking this will have isomers. Doesn't matter, we're only going to draw one of them today, so whichever one you draw, that's fine. And then we're going to add these ligands. So all we need to do is look up here for what they look like. It's those oxygens that are bonding, so put them on first. We've got a bridge going round here, so we put that on next. And then we add all the other little bits to it, including that bonding in the middle. That's one. Put another one on here. So same thing again. Add the oxygens, add the bridge, fill the rest in, including that bonding. So what we're saying here is no matter what you get given as an example, all you need to do is look and think, there's the ligand, and there I'm copying it down to here. It won't be a very high marking question because really all they're asking you to do is to copy a diagram down and put it in the right place around this octahedral complex. But this is what we should end up with. It might be that you drew it with the OHs at 180 if you were practicing this, and that would be perfectly acceptable because we would have isomers. We'd have a pair of geometric isomers, and we'd also have a pair of enantiomers to go with this as well. But we'll be looking at that in a later video.